Hey, database experts and app developers, do you want to build faster and run bigger workloads? We've got you covered with an exclusive free download of DataStax Enterprise. DataStax Enterprise works with all the latest tools like Kafka and Docker with incredible throughput and the best security. Download DataStax Enterprise for free today by visiting DataStax, that's DataStax.com/download DSE. That's the DataStax Enterprise for free. Visit datastax.com/download DSE. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes. Today I'm talking with Joe Duffy, founder and CEO of Pulumi Corp. How are you, sir?
I'm excellent. Glad to be here, Scott.
I noticed I was over on the .NET blog at Microsoft, and they don't let everybody guest post, but there was an actual guest post from the Pulumi team about the Pulumi project, and I thought that was pretty cool. And so I was like, I'm going to start digging into this and learning about what's going on here. And it says infrastructure as code. What is infrastructure as code?
Yeah, it's not a term that many of us developers are familiar with. Certainly, even before starting Pulumi, I wasn't very deeply engaged in doing infrastructure as code. What infrastructure as code is essentially when you want to build a cloud application, maybe it uses containers, maybe it uses serverless, you need to deal with infrastructure. Infrastructure is the stuff that powers your cloud applications, the virtual machines, it's the clusters, the containers themselves. Infrastructure as code is a way of managing that infrastructure actually just using code. So instead of completely stepping outside of your programming language, your editor, to go deal with infrastructure, you can actually just program it from within your code. And by doing that, you get automation. It's basically just like all the benefits of writing code. It's automatic, right? You can automate things. You can version it like code. You can collaborate on it like code. It works in your editor. You can share and reuse things with package managers. All the stuff we know about code now applies to infrastructure.
Interesting. Okay. So I just Googled something real quick because many, many, many years ago, if you go and search for PowerShell large-scale Hanselman, it looks like July of 2007. So 12 years ago, PowerShell 1.0 was out, and this is a very long time ago. I wrote a white paper called Managing Large-Scale System Deployment with Windows PowerShell. This is like before we knew what the cloud was. So large scale was not quite a thing yet. This is even before, I think, the idea of DSC, desired state configuration. And we went and built out data centers with PowerShell. And one of the things that we struggled with was this idea of declarative versus programmatic. Do you make an engine versus do you describe what you want? And then if you do describe what you want, how do you get into that state? And how do you avoid invalid states? And again, 12 years ago, but it was basically an XML file that described a pod, that described an environment and the different roles of stuff. And then we had an engine that was built in PowerShell that basically did whatever it could to get the system where we wanted. But this is XML and WMI and COM and DCOM, and it was cool, but not really very reliable. Were we reaching for some nirvana that we're starting to actually hit with products like Pulumi?
I think so. In the last, 10, 12 years, let's say, the term DevOps has come into being. We've seen tools like, frankly, PowerShell, but also things like Chef and Puppet, Ansible, SaltStack. A lot of these technologies have become popular and commonplace. And the modern cloud is far more programmable by its very nature. The Azure platform, it exposes APIs for literally everything that it does. And so it used to be the case there's a very human-driven activity to do anything with IT, anything with management. You'd have consoles that you point and click around. Now everything has an API. And so that enables you to now build programming models on top of those APIs. And that's ultimately why Pulumi is possible. Now, still, a lot of infrastructure as code tools these days still use JSON or YAML, not XML anymore, but similar concept where you're basically expressing a desired state using a markup language. And the problem with that is modern cloud architectures, it tends to be a lot of moving pieces. There's a lot of complexity. And so actually using a programming language to declare your desired state, and that's a key important differentiation, that Pulumi is still desired state based, even though you're writing code in a full-blown programming language. But you don't have to recreate the wheel all the time. You can use everything we know and love about languages and apply it to desired state. So if you have patterns that recur from time to time, you can express those. But absolutely, the progress in modern clouds is really what enables these sorts of tools to exist.
So it's that programmability. I was presenting recently and someone said, well, what's the cloud? The cloud is just other people's computers. And I was like, yeah, that's part of it, right? But it's being able to programmatically talk to it and say, I want something, and you do the racking of the machine. You add more memory. Like you and I were the cloud back in the day. It's like, hey, I want to scale out. All right, I'll go buy a machine and I'll rack it. And now what the cloud is its elasticness, right? That's the magic of the cloud.
It is. It's the magic of the elasticity, the reliability, the global availability. We work with a lot of big companies that still have to manage data centers across the world, and that's expensive business. And frankly, you're probably not going to be as good at it as, say, Microsoft's operations team, who can make sure that Azure continues to run reliably. And Microsoft's got a lot of really smart engineers building these cloud services and making sure that they're reliable and fail safe and built in a performant and scalable way. Mm-hmm. And you can leverage all of that expertise by using the cloud instead of having to develop it on your own.
So back in the day when I was kind of like probing this space 10 plus years ago, it was trying to be a declaration, right? We're all trying to create a DOM effectively that describes the state of our data center, right? And Pulumi lets you do that DOM, that description, that object model, but in whatever language makes you happy?
Effectively, yes. So Pulumi is multi-language. It's a runtime. So at the core, at the heart of it is exactly this sort of DOM. It's like a cloud object model that represents all of the different cloud capabilities. And although we work great on Azure, we also support, AWS, Google Cloud, Kubernetes, which is, really important to us. We have actually 36 different providers, and each one of those is essentially a DOM.
36?
And then we project.
Wow.
Yes. Yeah. So DigitalOcean, New Relic, Datadog, GitHub,
wow.
GitLab. Because it turns out, modern cloud isn't just about the cloud. It's also about SaaS, right? Oftentimes you're using, maybe MailChimp to send email from your application. Maybe you're using New Relic to do performance monitoring. And all of that is infrastructure that you need to manage and provision. So we support that. And then we basically project that DOM into all the different languages we support. The reason why you saw the .NET post is we just added .NET Core support. So you can actually write your infrastructure as code using C#, F#, Visual Basic. We haven't yet dusted off the Fortran or COBOL versions, but that's coming. And also PowerShell. And so it's super powerful. You can use TypeScript, Python, whatever suits you. So by doing that, you're getting a familiar language. But more than that, you can benefit from the ecosystems of tooling that has been built around these different languages.
But who's the competition? Like I just said that I was messing around, and I only say it in the lightest of ways, 12 years ago, because everyone's been trying to do this forever. Aren't there other declarative programming languages or declarative formats for cloud? How does Pulumi relate to those?
Yeah, it's interesting, along this journey of DevOps and infrastructure as code, the term infrastructure as code is probably 8-10 years old. If you look on Wikipedia, there's a lot of examples. I mentioned, Chef, Puppet. And those tools were more around virtual machine configuration. And people still use those tools. But now as we're moving more towards container and serverless architectures, they're used less and less frequently. And in its place, because of this desired state model, we've sort of reverted to writing everything in YAML, JSON, and domain-specific languages, which then hits the wall at some point. So a lot of times, we'll see, hey, we copy and pasted the same YAML, over and over again. We needed 10 instances of this certain resource configured basically the same. And because YAML doesn't have for loops, we basically copy and pasted. And so instead of having 10 lines of YAML, we have, 100 lines of YAML. And it starts to get unwieldy because, imagine you fix a security problem And now you have to go track down everywhere else you copy and pasted that same problem. And for some of our customers, maybe they're consultants, they're dealing with, dozens of client accounts. And now they have to go back to their customers and say, hey, that YAML I gave you last week, we need to go, fix it. And so especially with the current cloud, modern cloud is very fine grained. There's lots of resources to manage, from AI, ML services, databases, object stores, serverless functions. At that scale, the level of complexity we're seeing, just the approach of using YAML in domain specific languages is just breaking down for most people that we work with.
How much of this is declarative? Like, I like what you said about a cloud object model. And how much of it is programmatic? Like, you made a comment about a for loop. We had similar problems when we were trying to express these things in XML, where we were trying to decide, are we going to be fully like, this is a picture of what it should look like, figure it out, or are we going to try to put in functional and programmatic constructs and try to program our way out of this problem?
Yeah, so sometimes I joke that that Pulumi is actually imperative.
Imperative.
I shouldn't have even said that. It's basically the DOM itself is declarative, but you're using an imperative language or functional. Frankly, if you pick F#. So we've basically decoupled the notion of how you express your intent, which is done in a language, with the desired state. And the key is that DOM is something you can analyze. We actually give you the DOM. We actually say, before we do a deployment, we say, hey, here's the DOM, here's the desired state that we think you want. Is this correct? No? Okay, well, we'll show you, in your program where you created this object, you go fix that and then say, hey, let's give it another, try. And then because we have that DOM, we can always diff, so we know, hey, you're changing this one property, or you're creating a new instance of this. And all of that integrates for us with, a lot of people do Git-based workflows where they're actually pushing code between environments. And so we can integrate with GitHub pull requests to show you the DOM. And so it's really the marriage of the real, general purpose languages with this DOM concept that makes Pulumi unique.
Is the abstract syntax tree of it all, is it idiomatically the language that you use, or is it some intermediate language that's halfway to where your engine consumes it?
Yeah, it's actually one analogy I kind of draw based on my background sometimes is it's almost like, think of how COM worked, right? Where, COM, you had projections in different languages. Ultimately, there was the COM object model. There was an IDL that kind of described what that core object model was. And then there was an idiomatic as possible projection into each of the languages. So like Visual Basic, you didn't have to think about ref counting, because in Visual Basic, we didn't want that. But then in C++, all the ref counting was at your fingertips, and all the GUIDs and everything were there. And so it's kind of a similar thing with Pulumi. For example, our Go SDK, we built that to be embeddable inside of other products. And so we actually have a lot of people that are building larger systems that embed that in there. So it gives you a little bit more information about the DOM that you can control. Whereas, our TypeScript language support is really targeting sort of the Node.js developer who really wants to just create these objects and stitch them together and use the Node ecosystem to do that. And so it's definitely projected idiomatic into each language, but there's this common core to it, which is really important, especially when you're doing, policy enforcement and security, and if you want visibility across your organization, knowing that there's this common object model that you can analyze and understand over time is really, really important.
Mm-hmm. And just to expand a couple of acronyms for folks that aren't of a certain age, you said COM and the component object model of pre.NET world to late 90s, and then the IDL, the interface definition language, which was like WSDL for in-process objects, and then later out-of-process objects. It was an interface definition. So there's this interface. You think of the cloud as an interface, and you then have a projection of that in idiomatic, whatever language makes you happy. And how many languages do you support?
So we support TypeScript, JavaScript, Python, Go, and then any .NET Core language, so C#, F#, and VB.
Hey friends, I want to introduce a new sponsor to you, HMA VPN. It's a VPN you can count on. As you know, I do a lot of travel, and I tend to connect to a lot of untrusted wireless networks, and I probably shouldn't, but I can use HMA as the world's largest VPN service. It offers the most server locations worldwide, covers 190 countries. There's always a server nearby. It doesn't log your IP address, and it allows me to connect 5 devices simultaneously. It works on basically all platforms: Android, iOS, Mac, Linux, Windows, routers, wherever. It's actually been completely redesigned recently to make it even simpler and more fun to use. And there's even a smart kill switch that'll turn the VPN automatically on when you launch sensitive apps. Here's your call to action, my friends. Try HMA VPN risk-free with a 30-day money-back guarantee. This deal is for Hansel Minutes listeners. That's hmavpn.com/offer hyphen Hansel Minutes. That's hmavpn.com/offer dash Hansel Minutes. And when we say idiomatic, right, the goal is to make it feel not like it's Google Translate, where it's like, well, I see that you're trying to speak Spanish here, but it's not really. You are honestly trying to make C# people feel comfortable, and they're doing C# type stuff while Python people feel they're comfortable when they're using Pulumi in their projection.
That's exactly right. So in C#, we use task parallelism and async methods, and TypeScript we're using promises, and Python we're using and even down to the level of getting the right casing and the right idiomatic naming constructs. We really want you to feel at home in your language of choice, and it's really important to us because we actually see, one of the founding team members, Luke Hoban, was at Microsoft previously. He actually was part of the founding team for TypeScript, and we often wondered together in the early days, as we add new languages, is each one additive, or are we basically just taking imagine there's 100 people in the world that would ever use Pulumi. Are we just, slicing up that 100, and dividing it across different language ecosystems? And what we're actually finding is it is additive. When we added .NET support, we connected with a totally different audience than when we added Python support. And so there's this, it's really important to us that we feel idiomatic, that we're at home, feel like we're at home for those end users, that you can use your favorite tools. Like if you have your own test framework that you're familiar with in C#, we want you to be able to use that. And so that's really core to what we try to do. And then frankly, it's the hardest part of supporting a new language for us.
Back to that horrible portmanteau that you just made there, the imperative versus declarative and imperative. There's places like I'm looking at the .NET specific SDK, and I'll make sure that we include links to all of this in the show notes. There's places where you'll say like deployment.run async, and then you'll build kind of with a quasi-fluent interface an object that like Cosmos app, and Cosmos app has these args. Parts of it feel like you're building a DOM, and then parts of it have very verb action, action verb type stuff like run async. Is it really running? Is it really doing something at that moment, or is that a lie?
Yeah, so it's basically declaring the deployment. When you run the program using the Pulumi CLI, it's going to first run the program and compute what we call a preview, sometimes known as a plan. And that's going to show you, it's going to say,
what
hey,
if.
The what if. It's like a dry run. And then the CLI will say, hey, is this what you want to do? Yes, no, or show me more details. If you click show me more details, it shows you, the full object graph. You can inspect it if something wasn't what you expected. If you hit yes, then it actually orchestrates the deployment, and it just basically applies the plan that it showed you. You can run these independently. Sometimes people, especially, the GitHub pull request workflow I mentioned earlier, a lot of times people want to see that plan and the pull request before they merge it. So they know that, hey, when I merge this pull request, it's going to deploy 3 functions and delete, a container and do all these things. And so that's how the CLI kind of works in tandem with the programming model.
When you want something big made in the cloud and something small doesn't work, how does an engine like Pulumi get you into that state? Like if something happened, how do you know if it was a transient thing where like, oh, well, AWS or Azure couldn't get you a big VM right now, but try again, versus, you ran out of money or something that stops you in its tracks? How can you get a plan that's close enough versus a plan that either succeeded or failed?
Yeah, it's a great question. And honestly, it's interesting being in our position because we tend to be the interface into all these different cloud providers for our end users. And so if something fails, it's our responsibility to make sure it's a great experience. And that's a philosophy we have on the team. It doesn't matter if, hey, Azure timed out for some reason, or, the person didn't have enough money in their account. Like we view that as core to our experience. We want it to be a great experience. Now, that said, it's difficult.
Hmm.
So what we do is when you do that preview step, we actually validate as much as we can. We actually go out to the cloud provider. We say, hey, here's what we're going to do. Does this look valid to you? Surface is basically, sort of our background in programming languages, right? You want to find as many errors as close to writing the code as possible. And so we do as much as we can in the editor as you're typing, red squiggles, and then during the preview. And the worst case is if it fails during a deployment. But even in that case, we come back and we tell you exactly what line of code it was. And another important thing is as you're doing deployments, Pulumi is transactionally checkpointing state so that no matter what happens, if you fail, you're in a known state. You can choose to roll back if you want, but you're always in a known, well-defined state. And so we've made sure that because things fail, right? Entire regions go offline, billing, as you point out, sometimes you might not have permissions to do the operation you're trying to do because you're in an organization that has locked down security permissions. Mm-hmm. So we've tried to make that a great experience. We also protect against common failures, like we do retries at the right time, in case there's a transient network problem, so that try to insulate you from as many of those failures as possible.
That's really significant because there is, going back to my naive implementation many years ago, when we got into we don't know what state we're in, but some stuff got made and good luck. It was basically just torch it and try again was the best we could do. There wasn't any kind of granularity, and there was minimal governance or policy management.
Yeah, and that's one of the biggest arguments for using an infrastructure as code tool is, that a sort of infrastructure maturity lifecycle that we see is, step one. Most people go into the Azure console or AWS console, point and click to provision some things. They're just exploring. They're learning. That's perfectly fine. Most people learn that way. And the problem then comes, hey, maybe you want a second copy of that. Maybe you want production and staging. Maybe you want to share it with a colleague and have them stand up their own copy, or you need to scale, to a new region. At that point, you need automation. And the obvious way to do automation is to open code, provisioning of new resources. But the problem is exactly what you point out, where if it fails, now your script has to think about every possible permutation of failure in every state transition. And that's what an infrastructure as code tool fundamentally does. It knows the desired state, and it knows how to converge on that desired state no matter what state you are currently in. And that removes a ton of complexity that you just don't need to think about anymore.
That is the trick, though. Like, all of this is trying to hide complexity, but also it shouldn't feel like a black box that is hidden so much that you just throw your wishes, into the well and hope that things work out nicely. So how do you find that balance? You said that you can give them line numbers. You follow it all the way back to the projection and say the engine failed here, but in your projection, that's line 26?
Exactly. We treat this. A lot of folks on the team come from Visual Studio and .NET and compilers and languages, and so we've treated the whole infrastructure as code experience like we would a programming language or a compiler. And frankly, over time, we love VS Code, and we're kind of integrating more deeply into that and bringing more things just closer to the development experience. And so, because we talk to people a lot of times when something fails. It's 10 minutes into a deployment. It's kind of already too late. Production is now potentially suffering an outage. And it's kind of like some transient failure. You had a pile of YAML, and it's not even clear where the failure came from. And so we're really trying to bring a great developer experience to infrastructure, mm-hmm. Which is pretty unique, I think. Because a lot of the, we've been on this journey for a long time, and I think our standards for what's acceptable in the infrastructure space are actually much lower than what our standards are in the application developer space. We're willing to tolerate messy, hard to diagnose failures for some reason. I think it's just historically how we ended up here. And so we're trying to revisit that.
The larger Pulumi kind of cloud development platform isn't just this runtime, right? There's tools, there's libraries, there's a runtime, the goal of which is to give you that consistent development, the consistent operational plane for everything. How much does it try to hide, like pretend that we don't even know what cloud we're on, versus how much is it really straightforward with you about the realities of what you're doing? Like, how much do you abstract away and how much do you decidedly not abstract away?
It's a great question. We intentionally so the system's sort of layered. We intentionally don't abstract away at the fundamental building block layer. So I think of it as, it's turtles all the way down, right? It's a programming language. So everything's classes and functions and things compose, but everything bottoms out at that, basically the DOM that we were talking about, where you've got access to every cloud provider, all of the resources and all the properties on those resources in their raw form. We don't get in the way. We don't want to abstract over it. If you're going to Azure using Cosmos DB, we want you to have the latest and greatest features and be able to use them fully. Now, where it starts to get interesting is we can actually give you helper libraries, but still the next layer up is still cloud specific. So you mentioned we're actually on the release an Azure blog in partnership with the Cosmos DB team, this distributed application concept, where oftentimes people, will provision a Cosmos database, but then their application isn't globally distributed. So it's not taking advantage of the latency savings of the database. And so we can give you a Cosmos application, a component is what we call it. And that just hides a lot of the infrastructure complexity, but you still know you're using Azure in that case. And so that's sort of like this middle layer where we can help you with common patterns. You can frankly build your own. And then we do see some people taming the complexity of having to do multiple clouds using abstractions. So one of our customers, they run in Azure, but they also have to run on-prem. And so let's call them Acme Corp. They were able to create, an Acme Corp virtual machine abstraction that knows how to, at deployment time, either go to Azure or go to vSphere, VMware vSphere on-prem. And that's allowed them, it's not completely hiding the complexity, but it helps to encapsulate some of the complexity and enables other people on the team to think at a different level of abstraction, right? So now application developers can create applications out of composing Acme Corp virtual machines without having to completely replicate their configuration for the two different environments. And so we see a lot, increasingly more of that, and we're really excited about the sort of blueprints and patterns there. But fundamentally, you can always pierce through the abstraction and get at the raw underlying cloud. And I think that's essential because you see some platforms as a service that have come in where it works great for sort of development, but then when you go into production, you have to completely rewrite everything because it hid too much from you. And so we're trying to strike a nice balance between that abstraction and the level of precision and control that most enterprises need.
Mm-hmm. So, given the space, which is arguably somewhat crowded, and has been developing since Puppet in 2005, what does Pulumi do that kind of uniquely sets it aside from the various and sundry list of a dozen similar, if not they're not directly similar, like one-to-one features, but like where do you say, oh yeah, you should use Pulumi rather than Foo?
My answer to this now is different than it would have been at the start. At the start, I thought it was, and honestly, it's more of a people thing than it is a technology thing. I thought it was technology. I thought it was, hey, general purpose languages, it solves a bunch of problems, technical problems, right? Package management, you get, better editor experience, sharing and reuse. What we're finding with is actually it's the fact that now infrastructure and operations teams can actually work with development teams together. Historically, they've had completely different stacks, right? So the dev team was working on their app stack, and then the infrastructure team was working on, Chef Puppet or what have you, where, and that sort of reinforced some of the silos where, if developers need new infrastructure, they file a ticket and they wait for the IT team to provision it, and then they get back, maybe a month later or a quarter later. Whereas now what we're seeing is, especially with the rate of change in modern cloud architectures and workflows that are unlocked by technologies like serverless, containers, and Kubernetes, we're actually seeing that infrastructure teams want to empower their developers to be a lot more self-serve. If a developer wants a queue or a pub subtopic or, a new container or a new Azure function or whatever it is, they want to be able to have their teams do that. But the infrastructure team wants to put in place guardrails to make sure that developers don't accidentally do the wrong thing. And so we see developers really like it because they get to use their favorite language. They basically supercharge their ability to build more powerful cloud applications. While at the same time, the infrastructure team feels comfortable and they can still get the management and policies and oversight that they need. And so it's really that developer appeal that I think sets it really apart from most of what's out there.
I noticed that I can go and install the Pulumi CLI. I can install stuff on my local machine. But just while you were talking, I went to app.pulumi.com, logged in with GitHub, said I use Azure and C Sharp, click, click, click. And now I'm doing it all in the cloud. And I've given like basically a one-liner that I run to get the things that I want to get. And what is the relationship between the CLI and this console in the cloud?
Yeah, so I often describe this using an analogy. So, the CLI you can think of as like Git, right? It's an offline tool. You can run it fully offline if you want. You can use it without our service, but our service is kind of like GitHub in the sense that Git plus GitHub is a lot easier. It just handles a lot of problems for you. If you want to use it in your organization, it makes it easier to share your projects. And so that's essentially what the Pulumi service is all about. The Pulumi service is, it's the default mode that we recommend people use that makes it just really reliable. So everything you're doing is, when I mentioned the transactional checkpointing, it's using the service to do that. It's giving you visibility. So if you do deployments, you're going to get full history. Similar to how GitHub gives you commit history, with Pulumi, you'll see your full deployment history. And because when you logged in, you did it with GitHub, if you're actually triggering deployments from GitHub itself, we'll actually show you the commit itself. So we'll show you every deployment, who performed the deployment, what commit it came from, what pull request it came from if you're using the pull request workflow. And then if you want to use a team, you can sign up a new organization. And that gives you all the standard things around an organization, like, role-based access control. You can more easily share and work and collaborate on shared projects. You can have, continuous integration so that you can get, service accounts where you're doing deployments automatically rather than manually. Mm-hmm. And then other features as well around just, security and compliance. And you'll notice that it's basically a SaaS model. Mm-hmm. And so that's the model for the company. We open sourced the whole SDK, though it's there. We didn't hold anything back. Mm. And the part that we charge for is just the SaaS. Now, it turns out there's a free tier as well for unlimited use. It's really just when you want to use, similar to how you get free, individual repos on GitHub, right? You get the same with Pulumi. But once you want to use organizations, that's when you pay. And even then, you get started. It's $50 a month for 3 people. It's pretty affordable at that point.
Okay. So would you recommend that people just hit app.pulumi.com, walk through the process? It's like a 5-minute thing to get a Hello World Pulumi app running, and then a weekend to take whatever they've already got going and set it up for themselves.
Yeah, absolutely. There's, app.pulumi.com. There's also, you just go to pulumi.com. There's these getting started buttons. We call it Action Blue. You click any of those buttons, it will take you through walkthroughs. And it, as you point out, it says, hey, which cloud do you want? Which language do you want? And then it just walks you through building a simple application. And then we've got over 100 tutorials now for lots of different application architectures.
Very cool. Well, thank you very much, Joe Duffy, for chatting with me today.
Yeah, thanks, Scott. It was a lot of fun.
This has been another episode of Hansel Minutes, and we'll see you again next week.